Hello interwebs, and welcome to the very last installment of the IMS project. This is an important moment. This is it. From here on out, it's pretty simple. It's basically a matter of putting things back on the way you took them off. But I do take a moment to replace the rusted old bolts on the exhaust with stainless steel ones. It was pretty easy to do with the exhaust out of the car and a solid surface to work on, but it's nearly impossible to do with the exhaust in the car from what I hear. So show you how to do that, and also give you a couple tips about how to get that pesky reinforcement plate back on. Then we torque the axle nuts, which is quite a job if you took them off, and start the car up for the first time. So exciting stuff. Let's do it. So I'm getting ready to install the exhaust and mufflers back on the car. There's a couple notes about this. On the whole, it goes in the same way it came out, which is to say, with great difficulty. There are a couple special notes, however. You do need to replace the gaskets that go on here. That's pretty important. And the other note is that I am replacing the old rusty bolts with stainless steel bolts. So these will go through here like this. One thing to note though is that while the top one just goes through like that, the bottom two are pressed in. So you have to remove them. That's a little bit tricky. To do this, I used a good sized hammer, a socket that fits over the back of the screw. So you can screw one of the old nuts on here, place the socket over the back of the stud there, and then with a pretty large hammer, key is just sharp, fast blows. There we go. That's one out. Okay. That's that. These are ready. We're gonna have 3 8mm stainless steel bolts in there like that, and the new sealing ring on there like that. We're ready to go. As you can see, things are coming along. Most of the installation is reverse of removal, meaning that it is a pain in the ass. Got the exhaust in. Couple notes about the exhaust. I would definitely leave everything loose until you've got it all fitted. Make sure everything from here all the way to the muffler is all lined up and working right. Because if it's not lined up, maybe you've got a bracket on a little bit differently, and that can mess things up. So fit everything together first before you tighten the bolts. And also be aware that some of the bolts adjust the position of the muffler. So it can be down too low or off center a little bit if you are not careful about how you adjust the muffler. But essentially, it's just kind of a lot of work, and the same basic idea as how it came off. I did replace these bolts, the ones that are just really prone to rusting, with stainless steel bolts. That seems to be working well. The gasket that goes in here is also the gasket that you have to replace every time you take it apart, so be sure you do that. And that's about it. I'll probably put the torque specs up on my website, so look at the cards for that. should be up there soon. But yeah, all the exhaust is in, the roll bar is in, and it's time to put the plate and cross beams on. Now, this is famously hard to do. I've left this back support bar a little bit loose because I can tighten it later, and it does adjust. So I want to know right where it should be by putting the plate on here first. And then one trick I've found is that these bolts right here are pressed in, so they're rigid, but you can push them out, and that helps you put the plate on a lot easier. So I'm going to do that right now. It's pretty easy to do if you have a floor jack, as I shall now demonstrate. So it's a good idea before you get started to thread a nut on here. This should help mitigate any damage to the bolt. And then move your floor jack underneath. And I'll just jack it up onto that nut. And there we go. One down. So now this is loose, and when I'm fitting my plate on here, I'll be able to move that a little bit to line things up. Always make sure you start the bolts in the front first. Since they're bolts, if they don't get lined up quite right, you'll cross thread them. And then, now that these guys are loose, I really only had to loosen one side. Get that on there. There we go. So, as with anything, the trick is just knowing how to do it. So, with these two loose and the back brace loose, it's really simple, but it can be really difficult. So I definitely recommend following those tips. Everything else is pretty simple. We're gonna put the cross braces back on, put all the bolts back on, torque everything up, and we should be ready to go. All right, I've installed the drive axles. And while it seems you can reuse the drive axle bolts as long as you degrease them and put new Loctite on it, you should not reuse the main drive axle right here. This is the one that gets 340 foot-pounds of torque, so an incredible amount of torque. So you must buy new axle nuts each time. You won't be able to tighten it with the car in the air. So just what I'm gonna do is just put it on there snug and then drop the car down, and then I'll tighten it. The car is back on the ground, which is exciting. And we have just one task remaining, which is to torque the drive axle nut. Now, these are the ones that gave me so much trouble when I was trying to get the things off. And it is worth noting, I just took the drive axles out because I needed to replace the boot and CV joint. If you didn't take the drive axle out, you don't have to mess with this. But if you did mess with this, there's a new wheel hub nut back on here. Or in German, as it is called, a Schlingerschnungsmutter. One word. Yeah, I know. Everything on a car is one word in German. But I digress. The wheel hub nut is back on, and it is now time to torque the wheel nut. Getting these wheel nuts off to begin with was quite a chore, as you may recall, because they are torqued really tightly. So putting it back on is also a chore because you have to torque it to 460 Newton meters, or equivalently 340 foot-pounds of torque, which is a lot. And I don't have a torque wrench that torques anything above 300 foot-pounds, and getting one that accurately torques above 300 foot-pounds of torque is pretty expensive. Since I will literally only use that torque wrench for this nut, probably, I didn't want to buy one. But luckily, I'm a nerd, so if you geek out with me, I will show you how I was able to come up with a way to torque these. Right then, here is our solution, basically. Say you have a bolt right here in orange, and you have a wrench on it. Torque is just the force that you apply on the wrench times the distance from the bolt that you apply it. So a simpler example of this is, say I apply 10 pounds to my wrench 1 foot from the bolt. Well, then I'm applying 10 foot-pounds of torque. Simple, right? Because 10 times 1 foot is 10 pound-feet. If I applied 10 pounds 2 feet from the bolt, then it would be 10 times 2, or 20 foot-pounds of torque. So the torque increases as I apply more force and as the distance from the bolt increases, which is why a breaker bar with a really long handle can get things tighter and get tight things looser than something with a short handle, because the distance matters in the force. I know that I need a torque of 340 feet-pounds. This little symbol stands for torque. So that's the torque that I need for my axle nuts. All right, so to calculate the torque of 340 foot-pounds that I want on my axle nuts, I just have to figure out what the force is that I'm going to apply on it and what the distance needs to be. Now the force that I'm going to apply on this axle nut is my weight, because I've decided I'm just going to put a breaker bar and an extension on there and just stand on the damn thing. So my weight, and then whatever distance it is. So to figure out my weight, bathroom scale, and of course I weigh a hulking 170. No, I don't. So my weight is the force, and I plugged that into my formula. I wanted 340 foot-pounds of torque. I'm applying 146 pounds, my body weight, and I just have to figure out what the distance is from the bolt that I'm going to stand on this bar. So plugging it all in, I figured out that it was 2.33. Now this is feet, so 2.33 feet. If you're using the metric system, kilograms and meters, it's much easier because you don't have weird fractions that you have to convert. But luckily for me, 2.33, that's just 2 1/3, and 1/3 of a foot is 4 inches. So that's just 2 feet 4 inches. So my distance right here is going to be 2 feet 4 inches. So all I have to do to get the correct torque on these axle nuts is to put my body weight 2 feet 4 inches from the axle. Now, if all of that is still complicated to you, here's the simple breakdown. Take the torque that you need, 340 foot-pounds, and just divide it by your body weight, and that will give you the distance from which you have to stand. So I'm going to go back out to the shop, stand 2 feet 4 inches from the axle nut, and when the axle nut can support my weight at that distance, it'll be torqued correctly. There's one final note, which is if the wrench is like this, and I stand here, or if it's like this and I stand here, the torque that I get will be a little bit less than 340 foot-pounds of torque. So I want it as close to level as I can. All right, that's it, simple. Okay, so here is my breaker bar with my 32mm socket, and this is the pipe that will give me the length I need. And I've already measured 2 feet 4 inches with this chalk mark. So I'm just gonna put this on here. I'm gonna tighten it by hand as much as I can, and then stand on it as described. Now, you'll probably want the parking brake on, and you will probably also want to chalk the wheels, because as you tighten them, it will want to roll. All right.
So that's pretty tight. So put it out there like that. And hopefully you're able to see the mark here. This is pretty level. And I do have a stand to kind of balance myself on. This is probably one of those do not try this at home things, because I'm sure all sorts of things could break, including bones. So just be forewarned, this is how I torqued my axle nut without a torque wrench. So I'm gonna put my foot right here. I've got something to balance on. I'm just gonna balance, not necessarily place any weight, but all right, now as you can see, I very quickly torqued it around to where I can no longer stand on it. And the problem is, at least with this socket, my nut spite is way up there where I can definitely not stand on it. So to solve this problem, all I need to do is roll the car forward just a little bit, because that will turn the axle nut as much as I need to get another bite on it. Go. Very last step, reinstall the cover with the tip of the Porsche logo pointing toward the tire fill valve. There we go.
So the car's been sitting for quite a while now, and the oil has drained out of it, and it has no oil pressure right now. So before I start the car, it's a very good idea for me to crank it over and just allow the engine to circulate the oil to where it needs to be, and also build up the oil pressure it needs. If I can just crank it, it will allow the oil to circulate without it actually running at idle speeds. So in order to do this, what I'm going to do is I'm going to pull the fuel pump fuse, because the car is not going to start without fuel pressure. And if it's been sitting for a while, it doesn't have any fuel pressure to start with. And then when you pull the fuel pump fuse, it won't build any fuel pressure, so it won't start. And this will allow me to just crank it over for a while and allow the oil to circulate and build up pressure. Really, this is a good idea anytime your car has been sitting for a while. So in order to do this, I'm going to just access the main fuse panel. It's right here by the driver's side foot panel. You can just pull out the top. There are little clips on the bottom, and here are the fuses. Now, very handy, on the back of the fuse panel, there's this piece of paper that lists all the different fuse locations. And the way the fuse locations are listed is they're by row. This is row A, B, C, D, like that. And then they start at the left and go like this. So this would be A1, A2, B1, B2, and the fuel pump is C4. So I'm gonna go to row C and then 1, 2, 3, 4, right there. Pull that guy out. So I'm just gonna leave that guy out of there. And now I can crank the engine as much as I want and it shouldn't start and the oil will just circulate. Okay, fuel pump fuse is out. I'm about to crank the engine for the first time. Hopefully it doesn't explode. That definitely sounded okay. So now we wait and we'll crank it again in a few minutes. Okay, I think I'll put the fuse back in and go for broke. It's now or never. And it didn't explode! That's it. The IMS project is done. It's been interesting and exciting. By far the biggest project I've ever tackled. But it proves that you can replace the IMS bearing on these cars even if you're just an amateur mechanic. I loved all your comments throughout the whole process. I'm going to publish one more video with the costs and time for this project. And then we will be moving on to other exciting projects. So stick with me, make sure you're subscribed because it'll be awesome.